Hi viewers, welcome to my channel. Today topic for GATE 2022 Syllabus for Aerospace, Aeronautical Engineering. General Aptitude. Verbal Aptitude, English Grammar, Sentence Completion, Word Groups, Verbal Analogies, Critical Reasoning, Instructions, and Verbal Deduction. Numerical Aptitude. Numerical Computation, Numerical Estimation, Numerical Reasoning, and Data Interpretation. Engineering Mathematics. Linear Algebra. Vector Algebra, Matrix Algebra, Rank of a Matrix, Systems of Linear Equations, Eigenvalues, and Eigenvectors. Calculus. Functions of Single Variable, Limits, Continuity and Differentiability, Chain Rule, Mean Value Theorem, Partial Derivatives, Maxima and Minima, Directional Derivatives, Integration, Line, Gradient, Divergence and Curl, Surface and Volume Integrals, and Theorems of Stokes, Gauss and Green. Differential Equations. First-order linear and nonlinear differential equations, higher-order linear odes with constant coefficients, partial differential equations, and separation of variables methods. Special topics: Fourier series, Laplace transforms, numerical integration and differentiation, numerical methods for linear and nonlinear algebraic equations. Aerospace engineering, flight mechanics. Core topics: basics, atmosphere, properties, standard atmosphere, classification of aircraft, airplane, fixed-wing aircraft, configuration, and various parts. Airplane performance. Pressure, altitude, equivalent, calibrated, indicated air speeds, primary flight instruments, altimeter, ASI, VSI, turn bank indicator, drag polar, takeoff and landing, steady climb and descent, absolute and service ceiling, cruise climb, endurance or loiter, load factor, turning flight, VN diagram, winds, head, and tail and cross winds. Static stability. Angle of attack, side slip, roll, pitch and yaw controls, longitudinal stick fixed and free stability, horizontal tail position and size, directional stability, vertical tail position and size, dihedral stability, wing dihedral, sweep and position, hinge moments, and stick forces. Special topics: dynamic stability, Euler angles, equations of motion, aerodynamic forces and moments, stability and control derivatives, decoupling of longitudinal. Space dynamics. Core topics: central force motion, and determination of trajectory and orbital period in simple cases. Special topics: orbit transfer, and in plane and out of plane. Aerodynamics. Core topics: basic fluid mechanics, conservation laws, mass, momentum, integral and differential form, potential flow theory. Sources: sinks, doublets, line vortex and their superposition, viscosity, and Reynolds number. Airfoils and wings. Airfoil nomenclature, aerodynamic coefficients, lift, drag and moment, Kutta-Joukowski theorem, thin airfoil theory, Kutta condition, starting vortex, finite wing theory. Induced drag, Prandtl lifting line theory, critical and drag divergence, and Mach number. Compressible flows. Basic concepts of compressibility, conservation equations, one-dimensional compressible flows, Fano flow, Rayleigh flow, isentropic flows, normal and oblique shocks, Prandtl-Meyer flow, and flow through nozzles and diffusers. Special topics: elementary ideas of viscous flows including boundary layers, and wind tunnel testing, measurement and visualization techniques. Structures. Core topics: strength of materials, states of stress and strain transformation, Moore's circle, principal stresses, three-dimensional Hooke's law, plane stress and strain, failure theories. Maximum stress, Tresca and von Mises, strain energy, Castigliano's principles, analysis of statically determinate and indeterminate trusses and beams, and elastic flexural buckling of columns. Flight vehicle structures. Characteristics of aircraft structures and materials, torsion, bending and flexural shear of thin-walled sections, and loads on aircraft. Structural dynamics. free and forced vibrations of undamped and damped SDOF systems, and free vibrations of undamped 2DOF systems. Special topics: vibration of beams, theory of elasticity, equilibrium and compatibility equations, and Airy's stress function. Propulsion. Core topics: basics, thermodynamics, boundary layers, and heat transfer and combustion thermochemistry. Thermodynamics of aircraft engines. Thrust, efficiency and engine performance of turbojet, turboprop, turboshaft, turbofan and ramjet engines, thrust augmentation of turbojets and turbofan engines, and aerothermodynamics of non-rotating propulsion components such as intakes, combustor and nozzle. Axial compressors. Angular momentum, work and compression, characteristic performance of a single axial compressor stage, efficiency of the compressor, and degree of reaction. Axial turbines. Axial turbine stage efficiency, centrifugal compressor, centrifugal compressor stage dynamics, inducer, impeller, and diffuser. Rocket propulsion. Thrust equation and specific impulse, vehicle acceleration, drag, gravity losses, multi-staging of rockets, classification of chemical rockets, and performance of solid and liquid propellant rockets. Thanks for watching my channel. Please like, share and subscribe.